Good morning, everyone. Today we're going to focus on special right triangles, the 45, 45, 90, or the 60, 30, 60, 90 in the long run. There's one thing I do want to go over first, which is the standard position of an angle. So what we did last time in 8.1 is we did the Pythagorean theorem, we did all 6 trig functions, so on and so forth. But this time we're going to kind of go backwards. This is actually good practice for your ACTs or SATs, depending on what you're taking. Now, some of you might have printed this off already before I changed it, and there was the Pythagorean identity up above here. We're going to ignore that right now and go down to the standard position. Now, it says if sine of theta equals 4/5 is in the first quadrant. Right now, all we're dealing with is first quadrant stuff, okay? If we were in other quadrants, we would have to deal with the negatives and stuff like that. But we're going to better understand those in 8.2 and 8.3, okay? So let's think of this. We're given a certain trig function and its ratio, and we have to find the other ratios. All right, first thing to do, draw a triangle. We're going to do it in standard position, which means we start with a triangle that looks like this. Okay. Now, the reason why I'm doing it this way is because this connects to the unit circle, which again, we will learn a little bit. In the unit circle, the angle or theta will always come from that center. Okay, so I'm going to put theta right here. Now, sine is what over what? Sine is opposite over hypotenuse. So the opposite is 4, the hypotenuse is 5. So now we're going to use the Pythagorean theorem to help us identify that missing side. That is a squared plus b squared, and b is what we don't know, equals c squared, and c is always the hypotenuse. And then we're going to solve. So we get 16 plus b squared equals 25. Next, subtract 16 from both sides. We get b squared equals 9. Take the square root. So b equals 3. Okay, now I'm going to plug that in. Now I'm going to look at my question and see what it wants me to find. In this case, it wants me to find cosine and tangent. So let's do cosine first. So cosine theta. Cosine is what over what? It's adjacent over hypotenuse. So the adjacent is 3. Hypotenuse is 5. And again, if you forget that, guys, you can always label your triangle. So that way it's easier to pick up. Opposite, adjacent, remember, is right next to, and hypotenuse. All right, let's do our tangent. Tangent of theta equals, well, remember, tangent is opposite over adjacent. So opposite is 4, adjacent is 3, and we're done. Let's try one more. So tangent of theta, again, I'm going to draw my triangle. There's theta. Now tangent is opposite over hypotenuse. Not hypotenuse, why did I do that? Over adjacent. Okay, so opposite of theta is 8. Adjacent is 15. Have to use the Pythagorean theorem to find that missing side, which in this case is the hypotenuse. So I have 8 squared plus 15 squared equals c squared. That's 64 plus 225? No. Why am I just double checking, right? Yeah, it is. It's early, guys. All right, add those two together. Get 289. Now, what I would do, guys, because some of you know your perfect squares and some of you don't, which is okay. The first thing is try to see if it's a perfect square. So I'm going to go on my calculator and say 2 square root of 289, which actually does give me 17. Now, you could have gone the long way and broken it down like a tree, but just in case, because I know and I recognize some of those perfect squares, that I can take the square root. Now, if when I took the square root that this came out to a decimal, then I know I have to do my tree. Okay, no decimals. All right, this time I'll do it ahead of time and I'll label my opposite, adjacent, and hypotenuse. So opposite was 8, adjacent, and hypotenuse. And now the question wants me to find sine and cosine. So sine of theta equals opposite over hypotenuse, so 8 over 17. And cosine of theta equals adjacent, which is 15, over hypotenuse, which is 17. And we're done. So you'll have a couple of questions like that to practice. But we're going to go into our special right triangles. So when we've been doing and solving for triangles like an 8.1, we've been using our calculator, right? We've been, to find the missing side, we've been using Pythagorean theorem, or we've been actually calculating it out given an angle in the calculator. The great thing about special right triangles is you don't need a calculator because there's a pattern each time. Okay? So I'm going to break this down to you. First of all, angles in triangles have a correspondence to their sides. So if the angles are the same, the opposite sides are also the same. So this happens to help us out with the 45-45. So angles correspond to their opposite sides. Okay? So you see how the 45s are the same. So their opposite sides are also the same. And we don't know them yet, so we're going to just call them X. Well, if these two are X and this is another missing side, let's just call that H. But the truth is we want everything in one variable. So how would we solve this in terms of X? Well, we can use the Pythagorean theorem, right? And that's the hypotenuse. So I have X squared plus X squared equals H squared. And we're going to solve for H. X squared plus X squared is 2X squared. Now, how do you get H by itself? We got to get rid of that square. How do you get rid of a square? We square root both sides. Okay, because this is multiplication, we can break this up. The square root of 2 is just the square root of 2. But what is the square root of X squared? The square root and the X squared. Well, the square root and the squared cancel, so we're left with X. So H equals square root of 2X. So if we know X, we can fill all these in. If anything, I'll do this example here to show you. So the first thing I want you to do when you get to your problems is I want you, as you can see, this is X, Y, square, 8 square root of 2. Okay, I actually want to change these variables. Let's do this as C and this is B. Okay. Now, This is A. And if you remember, the side across from the 45 should be the value of X. Okay, so I'm setting it equal to the side length right here. And then I'm going to solve. Well, it's already solved, right? Because 8 square root of 2 equals X. Well, B is also X. And remember, C is the square root of 2X. Okay, what does that mean? That means I can replace this 8 square root of 2 in both these X's. So that means this side is 8 square root of 2. And this side is 8 square root of 2 times square root of 2. Remember, this is the X and this is that square root of 2. This one's already simplified, so we're all set there. But here what happens. The square root of 2 times the square root of 2 equals the square root of 4. Well, what's the square root of 4? 2. So that means we have 8 times 2. What is 8 times 2? 16. So again, what we're going to do is we're going to set our side length equal to our ratio stuff up here, and then solve for X and plug X in where it belongs. We'll do another one together if we need to after you watch this video. All right, 30, 60, 90, where does that come from? Well, right now, if you see, I don't have a right triangle here. What is this? This is an equilateral triangle or equiangular. So each of these are 60 degrees. Okay. Well, just like I said here, the angles correspond to their side lengths, right? So if all the angles are the same, so are the sides. So I'm going to label these as X. Actually, I'm not. I'm going to, even though I want you to think of them as all the same, okay? Okay. I just want you to think of all as the same. Okay. If I drew down an altitude or height perpendicular means I make a 90-degree angle. If you see, because this was equilateral, it cuts it in half. So this is now a 30-degree angle. So that's where we get our 30, 60, 90. And I'm going to show you that this side is now twice this side. You see that? And the reason why I say that now, and this is why I erase those X's, is because now if I label this as X, remember that this side length is twice as long. Again, we're going to use the Pythagorean theorem. This is, let's say, side B. Because remember, H is the hypotenuse. So I get X squared plus B squared equals 2X. And don't forget, it's squared. So let me square that 2X first, which gives me 4X squared. Now we're trying to get B by itself. So B squared equals, well, how do I get rid of that X squared? I have to subtract it from both sides. So 4X squared minus 1X squared is 3X squared. And we're in the same position we were before. Got to take the square root. So we get B equals the square root of 3X squared. But we can separate that, right? The square root of 3 stays the same. The square root of X squared is X. So our ratio, and this is where I want you to keep in mind, the angle across from 30 is x. The side across from 30 is x. The side across from 90 is double that. And the side across from 60 is the square root of 3 times x. Okay. Now, again, because we are using x's, I'm going to change these variables, which was probably a good idea. This would be our c, right? So let's do this as a, and this is b. Okay, so we're solving for a and b. Now, I'm going to put in what this equals. So the side across from the 90, remember, is 2x. The side across from the 30 is x. And this would be 60. The side across from 60 is the square root of 3 times x. Okay, go to what we have. What we have is that 12 equals 2x. So what we're going to do is actually take that and solve for x, so we can just plug it into our sides. So how do we get x by itself? We divide by 2. So I get 6 equals x. And now I can plug in. That means a equals 6. B equals, and I'm going to put the 6 in front because that's on the outside, 6 square root of 3. And we're done. That was more of an easy one to do when it comes to the 30, 60, 90. So let's see if this next example gives us a little trick, okay? Let me plug this in. Let me do A and B. Again, it doesn't matter which side's which, as long as you correctly identify the ratio. So the hypotenuse, that side across from the 90 degree, equals 2x, remember, right up here. The side across from the 30 equals x. And the side across from the 60 equals square root of 3x. So now I got to solve for x and find out what these equal. So I get 12 square root of 6, that's what's given to me, equals 2x. Okay, how do you get x by itself? Divide both sides by 2. I'm going to show you this time because this is a little bit different. Remember that when we divide both sides by 2, guys, that you are only dividing the number up front. You're not dividing the square root. Okay, so this comes out to 6 square root of 6 equals x. So if we look, this side A equals 6 square root of 6. Okay, so we get that side, we got that side. Now let's do this one. This equals the square root of 3 times 6 square root of 6. We're going to have to do some math here, guys. Okay, so that's where we might come over and do some work on the bottom. When we multiply square roots, right, we only multiply what's inside the square root. So right now we have b equals 6 square root of 3 times 6 is 18. Be careful because we can reduce some of this. We can simplify it, right? So 18, let's break that up, is 9 and 2. 9 is 3 and 3, and that's a pair that we can bring up front. Remember, it's all multiplication. So b equals 6 times 3 is 18. Square root, what's left over is our 2. Now, I know this is a lot of work and it could be confusing when it comes to the answers. So what we want to do is make sure that we label our sides. So So let's go back to example 3. A side, which was over here, was 8 square root of 2. The B side, right here, was 8 square root of 2. And C came out to be 16. This might make it easier for you guys to organize your work. Let's do the same thing here. A, if we go back to our triangle, is 6. B is 6 square root of 3. And C equals what's given to us already, which is 12. Okay, I wrote B here, so I'm just going to add on to that. A gave us 6 square root of 6. And C was given to us as 12 square root of 6. All right, come back as a class. Let's practice some of these together. Some of these are going to be easier than the others. So take your time and ask questions.